Welcome to the ICAS Airboss Recognition Program module on building the Airshow layout. This module walks through constructing the Aerobatic box for Category 1, 2, and 3 airshows by hand in Google Earth, using nothing more exotic than the ruler tool and a calculator. There is no scripting and no automated KML generation in this method. Every coordinate you place comes from a measurement you took and a calculation you can defend to an FSDO inspector or a Certificate of Waiver reviewer. As a refresher on the three performance categories, Category 1 covers aircraft faster than 245 knots indicated airspeed and requires a 1,500-foot minimum show line distance. Category 2 covers 156, 245 knots at a 1,000-foot minimum. Category 3 covers aircraft at or below 156 knots at a 500-foot minimum. Every number in this module traces back to FAA Order 8900.1, Change 694, Table 3.1. Keep that citation in mind because it anchors everything that follows.
Here's what you will walk away able to do by the end of this module. And all four skills are built entirely inside Google Earth Pro with no scripting required.
You will establish the reference frame by reading true heading and threshold coordinates directly from Google Earth's ruler tool, with no magnetic correction needed since the tool reports true heading natively. Second, you will hand calculate offsets, converting a required distance in feet into a destination latitude and longitude using nothing but a calculator, and you will be able to defend that math to anyone who asks. Third, you will build the layout itself in Google Earth by placing typed coordinate placemarks, connecting them with the Add Path and Add Polygon tools, and styling everything to convention so the file reads cleanly. Fourth, and just as important, you will learn to recognize a non-compliant layout by identifying the 8 most common construction errors, catching them yourself before they ever reach a Certificate of Waiver package and come back with a rejection. The next several slides build these skills in order, starting with the reference frame. Step 1 is establishing the frame, and this is the foundation everything else in the module depends on. The aerobatic box is never sketched by eye. Every single offset you calculate later starts from 2 points you measure directly in Google Earth Pro, the desktop application, not the web version, which lacks the precision tools you need. Start by searching the airport identifier and zooming to the active runway. Open Tools, then Ruler, then the Line tab. Click one runway threshold, then the other. The readout gives you true heading and length live. And again, no magnetic correction is required since Google Earth reports true heading directly. Right-click each threshold and choose Add Pluck to lock in its latitude and longitude to 6 decimal places. That precision matters once you start projecting distances outward. Record both reciprocal headings, for example 157 degrees and 337 degrees, before you compute anything else. The diagram on this slide shows the runway centerline as your baseline. Distances measured along that heading are your show line offsets. Distances measured perpendicular to the right of heading are the crowd line and box offsets you will calculate in Step 2. The 2 threshold place marks, base and far end, are your only fixed reference points. With your reference frame established, Step 2 is knowing the minimums you're building toward. This table is the one you should have memorized cold. Category 1, aircraft faster than 245 knots indicated airspeed, requires a 1,500-foot minimum show line distance. Category 2, greater than 156 up to 245 knots, requires 1,000 feet. Category 3, 156 knots or less, or 2,250 pounds gross takeoff weight, or less for reciprocating aircraft, requires 500 feet. And a flyby, any category performing a flyby only with no aerobatics, still requires 500 feet minimum. That 500-foot floor is the number to hold on to. It is never waived for any spectator area, regardless of aircraft category, regardless of site constraints, regardless of how tight the ramp space is. You'll see that point come back explicitly in the decision check slide later in this module. These minimums come from FAA Order 8900.1, Change 694, Tables 3.1 and 3.1a, with the never waived 500-foot floor also reinforced in AC 91-45C. Everything you calculate from here forward measures outward from these numbers. Now that you have the minimum show line distances, Step 3 sizes the box itself. The rule is simple. Box depth equals the outermost show line present plus 500 feet. The aerobatic box always extends 500 feet beyond whichever show line sits farthest from the crowd, on the performer side. The critical detail here, and one of the more common mistakes airbosses make, is that box depth changes only with the outermost category present at your show, not with how many categories are flying. If your show runs Category 3 aircraft only, your outermost show line sits at 500 feet, and your total box depth is 1,000 feet, that 500 plus the 500-foot buffer. If Category 2 is your outermost category, your show line sits at 1,000 feet, and your box depth becomes 1,500 feet. If Category 1 is present as your outermost category, your show line sits at 1,500 feet, and your total box depth is 2,000 feet.
Notice that adding Category 2 or Category 1 aircraft to a previously Category 3 only show doesn't just add a new show line, it pushes the entire box boundary outward to match.
The box floor begins at the surface, and its north-south extent runs the full length of the runway. This comes from 8900.1, change 694, section 3-148C3. With the frame measured, the minimums known, and the box sized, here is the build sequence in order, 5 steps, all performed inside Google Earth. Step 1. Fix the crowd line. Calculate or ruler measure the crowd line position, then use Add Classify to lock it in. Every offset that follows in the rest of the build measures from this point, so get it right first. Step 2. Compute the show lines inward. Calculate each category's coordinates using the worksheet method from Step 2 of this module, then add plus analysis of base show line. Step 3. Set the box boundary. Calculate the box corner coordinates using the depth rule from the previous slide, then connect them with Add Polygon. Step 4. Place the corner markers CM1 and CM2 500 feet beyond each end of the spectator area. These define the limits within which spectators may be seated or standing, and we'll cover them in more depth later in the module. Step 5. Verify separations. Remeasure every line with the ruler tool before you save the file. If a number is off, recompute it. Never drag a point by eye to fix a measurement error. That habit is exactly how non-compliant layouts get built. The next 2 slides show you what a correct FAA-approved layout actually looks like before we get into the coordinate math. This is the FAA's own reference layout, reproduced from Order 8900.1, change 694, figure 329, titled Example of an Airshow Layout for AF, Crash, Fire, and Rescue. Look at how the geometry stacks. Running parallel above the active runway are the 3 show lines. Category 1 line at 1,500 feet, Category 2 at 1,000 feet, and Category 3 at 500 feet, all measured from the crowd line at the bottom. The crowd line itself runs along the near side, shown as a thick blue boundary, and it's shaped with angled ends rather than a straight rectangle, tapering back from the corners. Show center sits at midfield on that crowd line, right where the show control position is marked. Notice the emergency response layout built around the crowd line. CFR, Crash Fire Rescue. Positions are staged at the corners and at show center. EMS ground units are spotted inside the crowd line perimeter, and an EMS helicopter pad sits off to one side, clear of the box. 2 dotted lines extend from the crowd line's outer corners. Those are ambulance egress routes, planned in advance rather than improvised during an emergency. Every element you'll build in this module, the show lines, the crowd line, the corner markers, and the essential personnel positions, appears in this one official diagram. Keep this image in mind as your target shape. Here's a second official example, reproduced from Order 8900.1, change 694, figure 324, and this one addresses a problem you'll run into at almost any site that isn't a wide-open military ramp. Obstacles inside the box. The diagram shows the show line running as a dashed center line down the middle, with an aircraft symbol on it to represent the flying display area. On the spectator side, to the left, the primary spectator area sits behind its own boundary, with corner markers at each end, and it's measured at 1,500 feet from the show line, matching a Category 1 show. On the opposite side, to the right, is where this figure earns its place in the module. The shaded gray zone sitting inside that same 1,500-foot flying display area And inside that zone are buildings and roads. The note at the bottom spells out the compliance requirement directly. For this site layout to be approved, every building inside that highlighted zone must be vacated, and road access into it must be denied for the duration of the display. This is the practical lesson. A show line distance isn't just a number you calculate and forget. It's a zone you have to clear of occupied structures and open roads before you can fly it. We'll return to this exact obstacle principle, that obstacles never reduce a minimum distance, in the decision check slide later on. Now, for the math you do before you ever click inside Google Earth. This is the core calculation of the entire method. Converting a distance in feet into a destination latitude and longitude. Two constants drive it. 1 degree of latitude equals approximately 364,566 feet, and that value holds constant everywhere on the globe. 1 degree of longitude equals that same constant times the cosine of your latitude, and because of that cosine term, a degree of longitude shrinks as you move away from the equator. It is not a fixed distance the way latitude is. From those two constants, the offset formulas follow directly. Delta latitude equals distance in feet times the cosine of your bearing divided by 364,566. Delta longitude equals distance in feet times the sine of your bearing divided by the same constant, but this time also divided by the cosine of your latitude to correct for that shrinkage. Add those deltas to your starting point, and you have your new coordinate. Here's a worked example using KNUQ Moffett field, runway 14 left, 32 right, verified against AirNav data. The base threshold sits at 37.428.923 north, minus 122.054606, with a true heading of 157 degrees. The show center is 4,600 feet along that heading and 300 feet right of centerline. The table walks the resulting 5 points outward from there. The show center on the crowd line at 0 feet offset, the Category 3 show line at 500 feet, Category 2 at 1,000 feet, Category 1 at 1,500 feet, and the outer box boundary at 2,000 feet, each with its own calculated latitude and longitude. This worksheet is exactly what you'll type into Placemarks in the next step. With your worksheet of calculated coordinates in hand, step 3 is getting them into Google Earth. The screenshot on this slide shows the new pop dialog with a latitude of 37.418594 and a longitude of minus 122.044584, typed directly in, named Cat1N, that's the Category 1 show line north end from the Moffett worksheet on the previous slide. Here's the 5-step process. First, click Add, then Ploboy, or use the pushpin icon on the toolbar.
Second, in the latitude and longitude fields, type the calculated decimal degree values directly. Google Earth accepts either decimal or degrees, minutes, seconds format, but stick with decimal degrees since that's what your worksheet math produces.
Third, name the placemark by convention. Things like Cat1N, Cat1S, CM1, or Show CTR, so that lines and folders stay organized once you get further into the build. Fourth, click OK. This is the detail that makes the whole method work. The placemark snaps to the coordinate you typed, not to wherever your cursor happened to be on screen. There's no eyeballing involved. Fifth, repeat this for both ends of every show line and both ends of the crowd line. Once every point exists as a named placemark, you're ready to connect them, which is the next step. With every placemark typed in and locked to its coordinate, step 4 connects them into lines and shapes. Two tools do this work. Add Path draws your show lines and crowd line. Click the first placemark, then the second, and press Enter or double-click to finish. Depending on which 2 points you connect, that path becomes a show line, the crowd line, or an ingress and egress route for emergency vehicles. Add a polygon, build the Aerobatic box itself. Click each box corner in order, working around the perimeter, then close the shape back at the first point you clicked. That closed polygon becomes your Aerobatic box outline. The screenshots on this slide show both tools in the Google Earth toolbar and an example of each in use. One caution before you start clicking. Zoom in tight to an eye altitude under roughly 1,500 feet before you click anything. At typical viewing altitude, a careless click can miss a placemark by 50 feet or more, and that error then propagates into every measurement downstream of it. If a click misses, undo it immediately with Control-Z. Never nudge a point afterward to compensate. That's the same eyeballing mistake the whole coordinate typing method exists to eliminate. With the geometry built, step 5 is styling and organizing the file so it's usable by anyone who opens it after you, whether that's an FSDO reviewer or the next Airboss who inherits your site package. Color coding happens through Properties, then Style on the Color tab. Right-click any line or polygon to get there. Convention gives each element its own color. The Category 1 show line, the Category 2 show line, the Category 3 show line, and the Aerobatic box outline each get a distinct, consistent color so anyone glancing at the map can identify a line without clicking it. Folder organization happens in the Places panel on the left side of the Google Earth window. Use Add then Folder to create a structure, and the recommended set is Airport Reference, Runways, Aerobatic Box, Show Lines and Crowd Line, Spectator Areas, Corner Markers and Show Center, and Essential Personnel and ARF. Once the folders exist, drag each Placemark, Path, and Polygon into the folder it belongs in. This isn't cosmetic. A cleanly organized KML file is what lets a reviewer verify your geometry quickly instead of hunting through an unlabeled pile of lines, and it's what lets you find and fix a single element fast when you're remeasuring on site. This is what steps 1 through 5 actually produce, applied to a real site. Moffett field, KNUQ, runway 14 left, 32 right, the same runway used in the worked example a few slides back. The satellite image shows the completed layout overlaid on the runway. A yellow polygon traces the aerobatic box boundary, running the length of the runway and extending outward to the calculated box depth. Inside it, a red line marks one show line and an orange line marks another, running parallel to the runway at their respective category distances, with a green line along the runway representing the crowd line reference. At each end of the crowd line sit the corner markers, CM1 to the north and CM2 to the south, exactly where step 4 of the build sequence places them. Show center is marked at midfield, right on the primary crowd line, and next to it an orange box marked Airboss control point, with a star icon shows where the show director actually stands. 2 ARF staging areas marked with fire truck icons sit along the box boundary, one near show center and one at the far end near CM2. Every element on this map traces back to a typed coordinate from a worksheet identical to the one you saw in step 2. Nothing here was dragged into place. Moffett field showed the core geometry in its simplest form. This site, MCAS Yuma, KNYL, shows what the same method looks like once you layer in a full-scale, multi-category show with additional operational zones. The site map shows all 3 show lines nested outward from the crowd line in sequence. Category 3 closest in, Category 2 next, and Category 1 at the outer edge at 1,500, 1,000, and 500 feet respectively, exactly following the box depth rule from step 3. Since Category 1 is the outermost category present here, the box extends to 2,000 feet total. Beyond the core box, this site adds a primary spectator area and a secondary spectator area, shown as the shaded wedges south of the runway, each requiring its own separation distance from the show line, which we'll cover on the next slide. A pyrotechnics landing zone, marked PLZ, sits near the spectator areas, since pyro placement has its own sighting requirements independent of the aircraft show lines. And a hot prop area is marked further to the side, a zone where aircraft with engines running are staged and serviced, kept clear of both the spectator areas and the show boundary. This is the level of complexity an Airboss actually manages on show day. The aerobatic box is the geometric core, but the full site package layers several other constrained zones around it. You've built the layout, but the build isn't finished until you verify it. Step 6 is trusting the worksheet, then confirming it with the ruler tool before you save anything. 4 steps here. First, reopen Tools, then Ruler, then the Line tab, the same tool you used back in step 1 to establish the frame. Second, click the crowd line placemark, then each show line placemark in turn. The readout should match your worksheet, 500, 1,000, and 1,500 feet, within a few feet of tolerance. Third, click the 2 box boundary corners directly. The total depth reading should match the Step 3 rule. Outermost shoreline plus 500 feet. Fourth, and this is the decision point. If a measurement is off by more than about 10 feet, the placemark was typed or clicked incorrectly somewhere upstream. Go fix the coordinate. Do not drag the point to close the gap. That reintroduces exactly the eyeballing error this whole method is built to avoid. There's also a field technique worth knowing separately from this build verification process. On site, you can drag the ruler tool between two visible ground references to sanity check a layout quickly, without recomputing everything from scratch. Use that field technique to verify a layout you already trust, not as your original method for building one. Let's go back and expand on the corner markers you saw placed in Step 4, and again on the Moffett field example. CM1 and CM2 are placed 500 feet beyond each end of the primary spectator area, along the extended line of the crowd line. Their function is specific. They mark the limits within which spectators may be seated or standing, not a boundary for anything else on the field. That sighting requirement comes from 8900.1, Change 694, Section 3, 148F6, reinforced in Notice 8900.488, Paragraph T, and the Airshow Special Provisions, Paragraph 11. Beyond the corner markers, this slide covers a separate spacing requirement that trips people up. The separation distance between primary and secondary spectator areas, and it scales with your outermost aircraft category, same pattern as box depth. If Category 3 is your maximum category, the minimum primary to secondary separation is 1,000 feet. If Category 2 is your maximum, it's 1,800 feet. If Category 1 is your maximum, it's 2,700 feet. Each of these has its own citation. Category 1 under Section 3, 2.148D4, Category 2 under 3.148E4, and Category 3 under 3.148E4, and Category 3 under 3.148F2. Remember this the same way you remember box depth. It's driven by the fastest category present, not by how many categories you're running or how much space the site has. Let's test what you've absorbed with 4 compliance scenarios. For each one, decide compliant or not, and be ready to defend your answer the way you'd defend it in a Certificate of Waiver review. Scenario 1. The Category 3 show line is sited at 480 feet from the crowd line because the site has limited ramp space. This is non-compliant. The 500-foot minimum is never waived, regardless of site constraints, full stop, no exceptions for tight ramps. Scenario 2. A box boundary gets recomputed after Category 1 aircraft are added mid-planning, shifting the outer box boundary by 500 feet. This one is compliant. Box depth correctly follows whichever category is now the outermost present, exactly the rule from Step 3, so recalculating and moving that boundary was the right call, not an error. Scenario 3. An obstacle sits 300 feet into the Category 2 show line, and that obstacle gets used to justify reducing the show line distance to 700 feet. Non-compliant. Obstacles never reduce a minimum distance. That's Section 3.148C3, the same principle you saw applied to the buildings in Figure 334 earlier. The obstacle has to be cleared or the show line has to move somewhere else, but the minimum itself doesn't shrink. Scenario 4. Corner markers placed 500 feet beyond each end of the primary spectator area on the extended crowd line. Compliant, this matches the required corner marker rule exactly as built in Step 4. Here are the citations you should know cold, without having to look them up because you'll be asked for them. Minimum show line distances come from 8900.1, Change 694, Tables 3.1 and 3.1a. The rule that the Category 3 minimum is never waived comes from AC 91245C. The principle that the box floor sits at the surface and that obstacles never reduce a minimum distance comes from 8900.1, Change 694, Section 3.148C3. That's the one behind both the Figure 334 obstacle example and Scenario 3 from the decision check. Show line surface discernibility, meaning the line has to be visually identifiable on the ground, comes from Section 3 to 148C2. Corner marker placement, 500 feet beyond the spectator area, comes from Section 3 ZAR 148F6, and notice 8900.488, Paragraph T. Flight over primary spectators is governed by Section 3148H, and flight over secondary spectators by Section 3148I, two distinct sections worth not confusing with each other. And the Airboss letter of authorization itself comes from 8900.1, change 694, Volume 5, Chapter 9, Section 6. Treat this slide as your quick reference card. Every rule in this module maps back to one of these 8 citations. 3 ideas to carry forward from this entire module. First, every dimension in an airshow layout traces to an FAA citation. If a distance can't be defended with a citation, it's wrong, regardless of how reasonable it looks on the map. Second, box depth follows the outermost category present at the show. Not the number of categories flying and not how much space the site happens to have available. That single rule governs box depth, primary to secondary spectator separation, and several other measurements you've now worked through. Third, build the layout in Google Earth by typing calculated coordinates directly into Placemarks. Then verify every line with the ruler tool before you save. Never build by dragging points by eye. That habit is the root cause behind most of the non-compliant layouts that get bounced back from a Certificate of Waiver review. This module covered the full by hand method. Measuring the frame, calculating offsets, building and styling the geometry, and verifying it before submission. If you need the full computational methodology written out as formulas, or want to see how the same process gets automated into direct KML production instead of manual placemark entry, that's covered in the Airshow KML skill.